So first, let's discuss what the mean value theorem is. So if we have f of x at an interval a comma b, a closed interval, there needs to be two conditions that need to be met before we start using the theorem. First of all, at the closed interval a comma b, f of x needs to be continuous, which means that basically when drawing the graph, you cannot pick up your pen while drawing it. So no holes, no asymptotes, no nothing. This one satisfies it because, well, it's just one curve. And at the open interval a comma b, f of x needs to be differentiable. And in this example, a and b aren't differentiable because, well, they don't have any points like before or after it. But so that's why it's an open interval. So if f of x is differentiable from a to b, so no asymptotes, no vertical tangent lines, which means no cusps or corners, then that means there is a point C inside the interval, inside the open interval a comma b, that has the same slope, or the slope of the tangent line or derivative at that point, as the secant line. So these should be parallel. And the theorem does not give you what the point C is, but it guarantees that there exists a point C, and we're going to learn how to find that point C. So if that explanation was a little bit confusing or choppy or weird, I think doing a problem will just solidify it in your brain. Here we have a function f of x equal to x times x squared minus x minus 2 over the interval -1, 1, and using mean value theorem, we can find all the values of x that are in this interval, or the closed interval for this, that have the same slope as a secant line that touches these two x values. And first, we need to figure out if f of x is continuous and differentiable over this interval. And just by thinking about it, you can infer that it is, because there's no shenanigans going on with the function in between these points. So we can start by calculating the slope of the secant line. And to do that, we need to calculate the rise and the run. To calculate the rise, we need to find the y values at both of these points. So -1 will just be -1 times -1 squared minus -1 minus 2, which is equal to 0. And 1 is going to be 1 times 1 squared minus 1 minus 2. This is equal to -2. So the rise is going to be -2 minus 0 is equal to -2. And the run is much easier. You just find the difference between these two values, which is 2. So the rise over the run is -1, which is your slope of the secant line. And we can use the slope to find the x values that have the same slope in this interval. To do that, we need to find the derivative, or f prime of x. And for here, I might think we need to use product rule, but it's pretty simple if we just factor the x, or distribute the x into each of the terms. So 3x squared minus 2x minus 2. And we can set this equal to -1 because we know that's the slope. And now we just solve for x. So 3x squared minus 2x minus 1 equals 0. And we can factor this, making like this. And using the zero product property, we can figure out that x is going to be 1 or -1/3. But if you listen closely during the explanation, I said that the mean value theorem only guarantees the x values that are in between this interval without the brackets, so the open interval, meaning with parentheses. So even though we found that this has the same slope as the secant line, that's not what the mean value theorem guarantees. Instead, it guaranteed the value of 1/3, which is what we were looking for. And I know this could be a little hard to understand, so just a quick review of what we did in this problem. I'll draw a graph to explain it. And I'll draw the interval -1 to 1 should look something like that. So what we just did is we found the slope of the secant line. Well, first, we figured out that it's continuous and differentiable, which obviously it is if you think about it. And we found the slope of the secant line. And the mean value theorem states that there's one x value in between this interval that has the same instantaneous slope as the secant line, which means that derivative is the same and the tangent line has the same slope. So like it could be here, it could be here, it could be here. And we found that point using the mean value theorem, which is -1/3, be around here. And if we draw a tangent line, just approximating it, these two lines seem to be pretty parallel, which means that using the mean value theorem, we found the x value in this interval that has the same instantaneous slope as the average rate of change in the interval. Now, let's get into some practice problems. If you think you know how to do this one, then pause the video and try it. This problem says f of x is continuous and differentiable on the interval, the closed interval 6, 15. f of 6 is -2 and f prime of x is less than or equal to 10 for the interval. What is the largest possible value for f of 15? And again, for this problem, we use the mean value theorem. And our conditions are already guaranteed here is continuous and differentiable on this interval, so we don't even need to worry about that. What we do need to know is the slope of the secant line, and it says f prime of x is less than or equal to -10 for the interval, which means that at no point in between this interval is the slope of the tangent greater than 10, which means that if the slope of the secant was greater than 10, then the mean value theorem wouldn't apply. Therefore, it cannot be greater than 10. If you think about it, like we have 2 points here and whatever graph in the middle, if this slope is greater than 10, then that means, according to the mean value theorem, there is some point on the graph where the tangent line is greater than 10. And that can't be possible because it says it's less than or equal to 10 for the interval, if that makes sense. So that means that the secant line needs to be less than or equal to 10 for the interval, which means that the rise over run needs to be less than or equal to 10. So we can write f of 15 minus f of 6 over 15 minus 6 is less than or equal to 10. If you don't know what this is just the rise over run, or the slope of the secant, because we have y2 minus y1, x2 minus x1. And we know what f of 6 is, and we know what this bottom simplifies to. So this is just f of 15 minus, or plus 2 over 9 is less than or equal to 10. And we get f of 15 plus 2 is less than or equal to 90. And f of 15 is less than or equal to 88. And we're trying to find the largest possible value for f of 15, and judging by this, the largest possible value is 88. And that's our answer. Now, let's do this practice problem. If you think you know how to do this one, then pause the video and do it. This one says, apply the mean value theorem to f of x equals x plus 5 over x minus 1 over the interval -3, 5. So you might think that we should just jump right into finding the slope of the secant, but no, we have to figure out if it's differentiable and continuous over their respective intervals. So remember, it must be continuous over the closed interval, which is this, and it must be differentiable over the open interval, which is just this, but with parentheses. And if that's kind of hard to memorize, just memorize C. This is what I remembered. Continuous over the closed, and just remember that for differentiability, it's the opposite, so differentiable over the open interval. So if it's continuous over the closed interval of this, that means that there's no asymptotes, holes, or anything. But you can see that for this one, since is a reciprocal function with x on the denominator, x cannot equal 1, because if you have x equal to 1, you get 1 plus 5 over 1 minus 1. You get whatever over 0, and you can't compute that, you get a whole, or an asymptote in this case. And since x equals 1 is inside the closed interval, you cannot apply the mean value theorem. So if you have this on a test, you can just say does not apply. But of course, you need to prove it first. You can't just write that. You need to write proof that when x equals 1, it's not continuous. So everything that I explained and all the problems that I went through should teach you everything that you need to know to get familiar with the mean value theorem. If you're still confused or lost on anything, please leave a comment below asking us and we will respond. If you learned something from this video or if you enjoyed it, then please consider liking and subscribing.